Hi everybody. Today we're going to continue or pick up where we left off with the Mcas 2016. It's been a while, I think almost a week since I did the last one. So we're going to start out with an open response question. The idea behind these is to help you get ready for the Mcas this coming spring. And these are the older ones, so while the problems are very different in the way they're set up, the content is still quite relevant. So the idea is you should try this on your own first, and then watch these videos afterwards. So if you haven't tried this particular Mcas yet, you can find the PDF for it found in the video description. So anyway, let's get right to it. So Manila started an arithmetic sequence. The first four terms of her sequence are shown below. We have these numbers right here, 13, 9, 5, and 1. What is the common difference for Manila's sequence? So, excuse me, the common difference is the amount it's changing by each time, and it's going to be consistent. So we went down by 4. We went down by 4, and went down by 4. So the common difference would be -4. Okay. B. What is the sixth term in Manila's sequence? Find how you got your answer. So there's a few ways you could do it. You can use a formula, but you don't really need to because they already give you 4 of them, so you just need to find 2 more. So 13, 9, 5, 1. And we're decreasing by 4 each time, so this would be -3. And this would be -7. 1, 2, 3, 4, 5, 6 is the sixth term. You could show that by just subtracting. Okay, Nevin started a geometric sequence. The first 4 terms of his sequence are shown below. 162, 54, 18, 6, okay? What is the sixth term? So let's see here. C, 162, 54, 18, 6. So it looks like they're dividing by 3 each time, or multiplying by a third. Multiply by a third, I guess, is the best way to do it. Multiply by a third. So 1/3 of 6 would be 2. And then 1/3 of 2 would be 2/3. 1, 2, 3, 4, 5, 6, sixth term. There we go. We found that by multiplying by a third, or dividing by 3, however you want to think of it. Write an expression that represents the nth term of an Evans sequence. Okay. Let's see here. All right, so finding the nth term, we'll go with a sub n being the nth term. And that's going to be the first term, let's see, a sub 1. Let's remember how to do this. A sub 1 times the rate to the n minus 1. Let's see if that works. Let's double check that. So let's do 162. That's our first term. Times the rate, which is 1/3, to the n minus 1. So let's go with the third term. A sub 3. So I wrote a little too close to that. So it'll be 3 minus 1, which is 2. So 162 times 1/3 the second power, which is 162 times 1/9. And that should be 18. Let's see. 2 divided by 9. Yep, it worked. My memory serves right. I'll write that a little better here. So we have a sub n equals a sub 1 rate n minus 1. I remember when this Mcas came out, because nobody got this right, because nobody could remember this. I mean, you can figure it out even if you don't remember the formula, because you only see this formula for like a few days in Algebra 1, and then they expect you to know it, over a year later without much practice. So I don't remember seeing this required on the second generation Mcas. I'll have to double check. I can't remember if there was a problem that required you to know this formula. I feel like there was. So that is part D. The first 3 parts, not so bad. Last part. Okay. All right, let's see what else we got. What is one solution of the quadratic equation below? Interesting. So we're trying to find out how to make this equal 0. So you could factor this. I mean, you could trial and error it. Let's factor this. So the factors of negative 10 are 1 and 10 and 2 and 5. This is negative, which means they have different signs. So it's going to be x equals 0. And they're going to be mixed signs. And because they're mixed signs, we're looking for the factors to have a difference, and this is the difference because they're mixed. The difference is 3. So these two have a difference of 3, so it's 2 and 5. And it looks like the larger one is positive, so 5 is going to be your positive value. And 2 is going to go here. Let's just make sure that works. So let's distribute this. So x squared, and then negative 2x, and then 5x, and then negative 10, and x squared plus 3x minus 10. Yep, that worked. Okay. So this is it factored out, and we're going to see what equals 0, so it'd be negative 5 or 2. Okay, those are both of them. Box and whisker. So if you don't remember how to factor here, you could just trial and error it. You could just plug numbers in. I mean, you would eventually find 2 because you put 0, 1, 2, 3. You're probably going to start at 0, then put your numbers in. So even if you can't remember how to factor this, you could still do that with trial and error until you found a number. The box and whisker plot below shows the distribution of scores for the members of a bowling team. Okay, Jimmy's score is in the bottom 25% of the scores, but he does not have the lowest score. What is one possible value for Jimmy's score? All right, so the bottom 25% is right here, but it's not the lowest score, so he's not 40. So he could have 45. I mean, anything between 40 and 80, not including either. Not including either. Okay, that's weird. Some kid just went in my room, and he left. That was strange. All right, so yeah, so 45 would work. Anything between these two values would work, not including those. Okay. Ooh, another open response. Okay. The diagram below shows rhombus ABCD with a side length of 8 centimeters. Okay, rhombus, you remember, is a quadrilateral with 4 congruent sides. It's also a parallelogram. What is the perimeter in centimeters of the rhombus of ABCD? So perimeter is length around. So 8, 8, 8. So add them all together, you're going to get 32 centimeters. Okay. The measure of angle ABC is 60, so this is 60 degrees. Okay. What is the length in centimeters of diagonal AC? Diagonal AC. So they want to know what this is, this length. Okay, interesting. So let's see here. So let's think about, and I don't know if I'm doing this the easiest way because I haven't seen this problem in a long time, but let's just try to figure this out. All right, so we're looking for AC, the length of AC. Let's see what we know. Well, we know AC is part of a triangle. And we know that these sides are congruent, which means this is an isosceles triangle, which means these angles have to be the same because they're the base angles. We know this is 60, so we know there's 120 degrees left, right? Divide that by 2, because that's what these are, and we're going to get 60 degrees, which means these are also 60. So we actually have an equilateral triangle here. Okay, so because the angles are congruent, that means the sides are congruent, which means this is actually 8 centimeters as well. So 8 centimeters. What is the length in centimeters of diagonal BD? Okay, let's see. So we can figure this out now because, let's see here. So looking for this one, we know that this is, okay, hold on a second here, this is a weird one. So we know that the diagonals of a rhombus are perpendicular, which means this is a 90-degree angle. So we have a 60 and 90. This is a 30. The diagonals also bisect the angles. So we have a 30, 60, 90 triangle here. So that will allow us to solve for this. We could also use Pythagorean theorem because we know this would be 4, 8. We don't know what that is, but I guess we'll use Pythagorean theorem because we know this bisects. We'll do both. We'll show you both ways to do it. So first we do 30, 60, 90. So let's go to our reference sheet. We're used to using that. So 30, 60, 90 is right here. So this is the 30-degree angle. So this is our x. This is our 2x, and this is our x radical 3. So our x is going to be half of that. So 2x is 8. Yeah, that means x is going to be 4. This is 4. I'm running out of room here. Getting a little messy. This is 4, and this is 4 radical 3. So this thing is 4 radical 3. That means there's 2 of them here. This would be 8 radical 3. Let's do Pythagorean theorem. So we'd have 4 squared plus b squared, we're going to call this b, equals 8 squared. So 16 plus b squared equals 64. Subtract 16 from both sides. And we're going to get b squared equals 48. To the square root of both sides. Make sure I did that right. 48 degrees. And we have 8. Something happened here. I think I screwed this up. Let's see, because I'm not getting the same thing here. So b equals radical 48. I can simplify that. Let's see. We're going to get, let's see. So 2, 24, 2 and 12, 2 and 6, 2 and 3. So let's see. 2, 24, 2, 12, 2, 6. Okay, so we have 4 2s. So 4 on the outside and 3. 4 radical 3, yeah. So 4, no, it worked, okay. It's right because I'm solving for one side. Okay, my brain was like not functioning there. I was getting confused because I knew this wouldn't be large enough, but it's only half of it. So yeah, so this is 4 radical 3, that works, okay. I think the 30, 60, 90 formula actually is much faster than the Pythagorean theorem for that one. What is the area of the rhombus? Okay, so, let's look at our formula sheet. I don't remember seeing area of a rhombus. I don't see it there. No, it's not there. But we can figure it out because we can find the area of the triangle and just multiply that by 4. So area of triangle is going to be 1/2 base times height. So base is going to be 4. And then the height is going to be 4 radical 3. So let's see what this is. So 1/4 times 4 is 1. Wait, what is it? Why is it 4th? Okay, let's rewrite that without me being silly here. 1/2 base times height. Okay, the base is going to be 4, so 1/2, 4. The height is going to be 4 radical 3. So half has to be 2. And 2 times 4 radical 3 is going to be 8 radical 3. So that's one of these triangles, is 8 radical 3. So multiply that by 4. Let's multiply that by 4. We're going to get 32 radical 3. It's actually not that bad. Centimeters squared. Okay. So that problem, where is that problem tricky? Well, the perimeter is not too bad. The diagonal AC takes a little bit of finagling because you have to understand that this is an isosceles triangle, and then when you realize these are both 60, that means that that's 60. So this is the part B is actually kind of tricky for a second part of a multi-part problem. They're normally not that challenging for the second part, and then being able to find the length of that diagonal right here, that requires you either recognizing this is a 30, 60, 90 or using Pythagorean theorem. Yeah, that's a tricky problem. That's definitely one of the more challenging ones I've seen where it gets really hard right off the bat at part B. So, okay. Is this the, yeah, this is the last one for this one. Then we'll finish it up. All right, so last problem here for session 1 rather. So we have, zoom in a little more so you can see this. Vivian and William are approximating the values of square roots and cube roots. Sounds like a great time. Vivian approximated the value of radical 15. What is the value of radical 15 to the nearest whole number? Show or explain how you got your answer. Okay, so part A, radical 15, what whole number is that closest to? So the first thing we're going to do is find out which two perfect squares it's in between. It's in between radical 9 and radical 16. So radical 9 is 3, radical 16 is 4. 15 is closer to 16 than 9, so that means it's closest to 4. So you'd say 4 is the closest whole number. Not that bad. Part B. William approximated the value of the cube root. So notice it's a 3 there. Cube root of 30. What is the value of the cube root of 30, the nearest whole number? Okay, so most people don't know these, and I don't know all of them by heart either, so let's just figure them out. So 2 times 2 times 2 is going to be 4 times 2 is 8. So the cube root of 8 is 2. Let's try 3. 3 times 3 times 3. So 9 is 3 to 27. So the cube root of 27 is 3. Let's do the cube root of 4, of whatever the 4 one is. So 4 times 4 times 4, so 16, 64. So the cube root of 64 is 4. So what is closest? What is cube root of 30 closest to? Well, it's definitely closest to 27, so it's closest to 3. Okay, part C. Vivian approximated the value of radical 35 to be 5 8/10. William found a closer approximation to the value of radical 35 than Vivian did. Okay. What could be the approximation William found? Show or explain how you got your answer. Okay, so this is really, really close. Let me zoom out a little more. This is awfully close to radical 36, which means this is awfully close to 6. What should be awfully close to 6? I'm guessing William could have done 5 and 9/10, so let's find out. So radical 36 is really close to 6. Radical 25 is 5. So it's radical 35 is very, very close to this. William found a closer approximation. Okay. So you could say 5.9 and get this problem right, depending on how much of an explanation they want. But I'll show you another way to do it. People get confused by it, but it does work. So first thing we're going to do is find the difference between 36 and 25. So think of it as like a number line. Let's say you had radical 25 here, radical 36 here. And you want to find out how many little marks there are, right? I think there should be 11. So 36 minus 25. Yep, there's 11 marks. Okay, so that's the distance between the two. And then we want to find out how far 35 is from 25. So 35, 25, would be 10. So 10/11ths. If I can figure that out as a decimal, I'm going to add that to the 5, and that's going to tell me what it's closest to. So yeah, it's going to be closer to 0.9, but I can already tell 10 divided by 11. Okay, we're going to go with 9. That's 99. Another one. And then we're going to go with 9. So yeah, it's going to be 5.909. It's going to keep going forever because that's going to be that's going to be how far that is. So we're going to say 5.9 or 5 9/10. So yeah, depending on how much they want an explanation, that one's not too bad. Okay, last part. Vivian approximated the value of the cube root of 1010 to be 10.0. William claimed that 10.1 is closer approximation than Vivian's. Whose approximation is closer to that? Okay, so let's find out what happens. There's actually a really quick way to do this. We can multiply each of these by itself and then find out which one is closer to that. So 10 times 10 times 10 is 1,000. And that is Vivian's. So that is 10 away. So difference of 10. That's the difference. We want whoever has the lowest difference is going to win this challenge. William. So 10, this would be a lot easier with a calculator. So 10.1 times 10.1 times 10.1. All right, so we don't have a calculator for this, just this old-fashioned way. And there's another way, you could do what I did here, but I think this is actually the quickest way to do it. 10.1 times 10.1. So, and then bring it over, 0, and then 2 decimals, so there we go. So 1 under 2.01 times 10.1. So 1 under 2.01. So 1, 0, 2, 0, 1. And 0, and then 1, 0, 2, 0, 1. 1, 0, 3, 0, 3, 0, 1. And there's 3 decimals. Okay. So they got 1,030, which is off by, what, off by 20? Because we're trying to get closer to 10? Yeah. So we got 1,000. Off by 30. Let's see, oh, sorry, off by 20. Let's see if I screwed it up. I don't think I did. 0.1 times 10.1 times 10.1. I did it right, okay. I wasn't sure if my math was off there. So yeah, this is actually 20 away. So even just by adding that 1/10 of it, that made it too large, so Vivian is the most accurate. Okay, excellent. Very good. So that's it. That finishes session 1. Hopefully that was helpful. You can see where the open responses are definitely a little more tricky. Like this one, the rhombus one was, I could see that giving a lot of people a hard time. Arithmetic sequence, not too bad, but the geometric stuff might throw some people off. And these two shouldn't be too bad. This one, worst case scenario, you could just plug numbers in until you figure it out. And this one, I don't know. I'd say this is a close second, but I think the rhombus one would have given people the most trouble. All right, guys, thanks for watching.